Hi everybody, welcome back. In this section we are going to be looking at two different topics. So I've actually decided to split them up as two separate videos. The first section that we're going to be talking about is something called linear approximations. And the second topic that we're going to be talking about is something called differentials. And these are very much related, which is why they show up in the same section in the book. But I figured they deserve their own video each. Okay, wow, that's pretty sloppy. Figure they deserve their own video each. Instead of making one video about a lesson and then another video with examples, I've decided I'd rather just do one video with linear approximations and include a couple of examples, and then make a separate video for differentials. They're both kind of talking about what happens if you have a function. So just going to kind of throw a function in here. And if you have a specific value of a, what happens as you get really close to that? So here's a point on the graph. This point is a comma f of a. And the question is, what happens if we have a value of x that is really close to a, but x might not be a very nice value? Okay, so how does the function behave at x, which is going to be really close to a? Okay, and so I hope what should be fairly obvious is that the closer x is to a, the smaller the distance in between them, the better we can approximate what's going to happen for this point right here, which is actually x comma f of x. So let's take a look at kind of an example to start out. Something that we're going to look at in just a second is, let's say we have a function, and we don't even need to define the function, I guess, here, but what if we're looking for an estimate of the square root of, let's say, 0.99. Now, I realize that we live in 2020, okay, and I realize that you can just grab your calculator and say, hey, what is the square root of 0.99? Okay, that kind of defeats the purpose of this section, though, and defeats the purpose of understanding what's happening behind the scenes. Because your calculator somehow is estimating this decimal as best as possible. Okay, in fact, it wasn't that long ago that we didn't have calculators and people had to be able to look things up in tables and to try to be able to find square roots and really difficult values. You just didn't have it right at your fingertips. And so the question is, what is your calculator doing behind the scenes? Now, it's a little more involved than what we're going to see here, but there's a lot of calculus that your calculator is doing behind the scenes without you actually knowing it. And so, to the best of our ability, we are going to be able to estimate and find the square root of 0.99, and I would encourage you to put your calculator away for this section and think about how to be able to do this without your calculator. Okay, so here's how we're going to do this. If we want to be able to estimate a value of f of x, we're actually going to use the tangent line approximation. And so another way to think about this is, let's look at a graph and think about, in fact, I'll go ahead and graph the example that we know we're going to see on the next page, which is using a square root. So think about a square root graph, and here's a function, square root of x as your function, and you know what happens at 1. There's a point on this graph, and specifically this point is the point 1 comma 1, because the square root of 1 is 1. And so if we're looking at 0.99 that's really close to that, there is another point right there. Okay, maybe I should draw that in a different color. Let me put that in blue. Okay, so there's another point right there, and that is really, really close to the point that we have. Now let me zoom in on that window and just kind of see what's happening there. If we zoom in on that, we have a little piece right here where we have the point in black is kind of right here maybe, and the point in blue is really close to that right there. Now I want you to think about what the tangent line of the function looks like at x equals 1. Okay, so thinking about the tangent line, we can find the slope of the tangent line. We've had a lot of problems this semester that have said not just find the slope of the tangent line, but could you find the equation of the tangent line? And if you look at this zoomed in picture and look at the equation, or look at the tangent line there, kind of goes like that. That tangent line has a value right here where x is the input. And so if you were kind of talking about down here somewhere, there's somewhere where x is the input in that tangent line, and like where this point is in black and this point is in blue, those are really, really close to each other. Like I'd need to zoom in pretty far in order to even see space in between them and see that they're actually different. There's a little bit of an error. But when we're finding f of x, what we're actually looking for is the blue point, okay? So maybe I should write it over here in blue. We're actually looking for the blue point, f of x, but in order to find f of x, that's tough to do, especially when you have an input value like 0.99. What we're going to do is we are going to use the tangent line and this black point right here to kind of estimate the blue point. They're almost the same point, not exactly, but they're really, really close. If you look at where the black point comes from, it comes from the tangent line. And so if you remember the equation for a tangent line, really just the equation of any line, I would remind you that you can write the equation of a line as y minus y1 equals m times x minus x1. And if you go ahead and move the y1 to the other side, another way to write that is to write it as y equals y1 plus m times x minus x1. And so the y over here on the left side is really the blue point that we're looking for, and the right side, the y1 plus m times x minus x1, is actually this black point that we're looking for, and we're saying, hey, those are really, 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 really close to each other. But they're not exactly equal. So here's the deal. We probably shouldn't say exactly equal in there. We should probably use some other notation instead to say that they're not exactly equal. They're just really, really close to each other. So here's how we're going to do that. We're going to say, hey, this is pretty much the same thing, but let me go ahead and use approximately equal instead. They're off by just a little bit. Okay, so if we want to find what f of x is equal to over here, we're going to say that f of x is approximately equal to, let's go ahead and relabel the y1 and the m and the x1 over here. Remember where the point came from? It was the tangent line close to this point right here that has an input of a, and actually an input of a, and then they have an output of f of a. So this point right here is a, f of a. That's the point we're going to use in the equation for the tangent line over here. Okay, so here's really what this looks like. And so this is called the linear approximation, or the linearization is another way to say it. I don't know why we always give like the longest names to stuff in math. But we're basically saying if we are looking for f of x, we can find that by finding f of a, that's another way to write y1, plus, let's see, can we come up with another way to write m? That's f prime of a. Remember, it's the slope of the tangent line at x equals a. And then times x minus, and then the x value of the point that we were using was a. So this is basically saying that the right side of the equation, or the almost equation, if you will, is talking about the black point that's here, and we're using that point to kind of estimate the blue point. And the blue point is the point that we really want to know about. That's the point that has not a very nice value. And so I'm going to erase this. You know where it came from. It came from the equation of a line. It came from that point slope form of a line. So let me just make a subtle distinction in here. When we are finding f of x, this is what we're going to want, by the way. I'm going to put a box around that and say we're going to come back to that. That's what we need. X typically is not a very nice value for us. Like in the example that I said we're going to work on in a second, x is the value of 0.99. That's not a very friendly value, okay? But a is a nice value that is really, really close to x, okay? So a is a nice value that's really close to x. All right. So in some of our problems, you're not necessarily going to be told, here is what a is. You might have to kind of come up with that on your own. For example, in the next problem, when we know we're looking for the square root of 0.99, here are some things that you should be able to come up with when you know that this is the problem you're working with. X is the not very nice value, like 0.99. A is a really nice value that's really close to that. I hope the obvious choice there is 1. And then we got to know, what is f of x? What's the function that we're plugging x into? Well, if x is 0.99, then f of x seems like it's talking about the square root of x. All right, so let's go back to our formula. if you look in the formula, we're trying to find f of x, and what we need is f of a. Let's see, we could plug in a into f of x. We know how to do that. We need x, we need a, and then we need f prime of a. So before we just go and kind of use everything, it might be helpful for us to be able to identify what is f prime of x as well. And this is where the derivatives come into play, obviously. And so when you have the square root of x, another way to write this, let's write it as x to the 1/2, so that when we take the derivative, it's 1/2 times x to the negative 1/2. Okay. Now we can go ahead and just plug stuff in. Remember, this part right here, this is like the blue part, f of x that we're trying to find. Okay. So we don't know exactly what it's equal to, so we're going to say approximately equal to, all right, remember the formula said f of a plus f prime of a times x minus a. All right, so let's go ahead and plug in what we know. F of a says plug in a into your original function f of x. So f of a is the square root of 1, okay, which is just 1. And then plus f prime of a. F prime of a is 1/2 times 1 to the negative 1/2. And then x minus a is 0.99 minus 1, okay? And so go ahead and simplify, see what we get. And again, remember, we're not finding exactly the square root of 0.99, but we are finding something that's really close. So here's 1/2 plus, okay, let's see, 1 raised to the negative 1/2 is also 1, so this is just a 1/2 there. And then be careful in the parentheses. The tendency is to look at the difference and say, oh, it's a positive difference, but remember, it's x minus a, so inside it's actually a negative 0.01. Okay. Let's see, so if you take a look at this and simplify, keep going, this is 1 minus, let's see, 1/2 of that is 0.005. And I should probably continue to use approximately equals all the way along the way. Okay, so approximately equal to, let's see, 1 minus 0.005 is 0.995. And that's approximately what we should get for the square root of 0.99. Now go ahead and do me a favor, grab your calculator, and you can double check this and see what we're supposed to be getting. Hopefully what you should find is something that's really close to this. So I got something like 0.994987. Wow, we were really close there. Okay, so I said don't use your calculator just to plug it in, but it is fine to just check and see were we actually close to what we wanted to get. All right, let's go ahead and take a look at one last example. Let's look at 1.999 raised to the 4th power. And based on what we saw earlier, you should be able to pick out some important information. First of all, x, which is supposed to be a not very nice number, is 1.999. A is supposed to be a nice number that's close to that one, so 2. F of x is x to the 4th. And f prime of x then, from that, is 4x to the 3rd. And if we're trying to find 1.999 raised to the 4th, we can go ahead and plug stuff into our formula. Remember the first part said f of a, so this is 2 to the 4th, plus f prime of a, so 4 times 2 to the 3rd, times x minus a, so 1.999 minus 2. And go ahead and simplify. This is 16 plus, let's see, 4 times 8, 32, times negative 0.001. Let's see, this is 16 minus 0.032, which should give you something like 15.968. So that's our approximation. If you go ahead and grab your calculator again, you should find that we're really close to that. 1.999 raised to the 4th, and my calculator says something like 15.968, 023 something, you know, keep on going. So we were really close to that, which is the goal here. Okay, hope you've enjoyed the video.